All right, let's talk about something huge. I mean, literally the biggest concept there is, infinity. It's this absolute cornerstone of modern math, right? But what if the big proof that defines our whole understanding of it is actually built on a mistake? Let's dive in. So, first, let's start with a classic puzzle. You've probably heard this one if you've ever dipped a toe into higher math. Are some infinities bigger than others? Now, your gut might say, no way, infinity is infinity. But the standard mathematical answer is, actually, yeah, they are. You see, the accepted view kind of splits infinity into at least two different flavors. First, you've got your countable infinities. Think of all the whole numbers, 1, 2, 3, and so on. You could, in theory, put them all in a list. I mean, the list would go on forever, but you could still list them. Then you've got uncountable infinities, like the real numbers. That's every possible number on the number line, including all the decimals and weird ones like pi. The argument is that you just can't put those in a list, no matter how hard you try. And this whole idea that there are different sizes, different levels of infinity, it's a massive pillar of modern mathematics. And really, it all comes down to the work of one guy and one very, very famous proof. And this is it, the big one, Cantor's diagonal argument. It's the super clever, really elegant proof that for more than 100 years has been taught as the final word on the subject. But the source material we're looking at today, it throws a major wrench in the works. It presents a direct and, honestly, pretty powerful challenge to this whole foundational idea. Okay, this is where it gets really spicy. Our source doesn't just kind of disagree with Cantor. No, it claims the entire proof is basically a magic trick, that it's built on a faulty assumption. It argues that Cantor confused a process that can never finish with a product that's already done. And that's a direct quote. Calling one of the most famous proofs in all of math vacuous and illegitimate? Whoa. I mean, those are fighting words. So what's the logic here? How do they back up such a bold claim? So to really get what they're saying, we have to look at how they take apart Cantor's logic. It's not that the steps in the math are wrong. It's that the conclusion he draws from them is, well, just totally misinterpreted. Okay, so check this out. This is the heart of the counter argument. Cantor says, imagine we have a complete list of every single rational number. Then he cleverly creates a new number that can't possibly be on that list. And he's like, aha, see, there's more numbers than can be listed. It's a bigger infinity. But our source slams on the brakes and says, hold on. All you proved is that your list wasn't actually complete to begin with. You just found a number you missed. So it all boils down to this. The source thinks Cantor made a huge mistake. He mistook an unfinishable process, the act of listing numbers forever, for a new category of number. Just because you can always find one more number to add to your list doesn't mean you found a bigger infinity. It just means your list is and always will be a work in progress. And this whole unfinishable list thing, it actually points to an even bigger idea from the source. It suggests that maybe it's not just this one proof that has a problem. Maybe our whole concept of counting itself just falls apart when we start dealing with numbers that are truly mind-bogglingly huge.
Let's step back for a second. Think about something super simple we all learned in school. F of x equals x squared. You take a number, you multiply it by itself, you put an x in, you get one clear answer out. Easy enough, right?
Right. But what if that x is just insanely big? I mean, a number so colossal that we couldn't even write down all its digits if we used every atom in the universe. What happens then? Well, according to this source, when you get to that crazy extreme scale, our math just stops working. It becomes physically impossible to do the arithmetic, impossible to even write down the answer for x squared. And at that point, the whole idea of countability, the very thing Cantor's proof is built on, just becomes completely meaningless. And that brings us to the final part of this whole argument. And honestly, it's a real mind-bender. It asks us to totally flip our perspective. It asks us to try and imagine what our entire number system looks like from the viewpoint of infinity itself. Now, this quote really nails the philosophical heart of it all. Imagine you're standing at infinity, looking back down the number line toward zero. What do you see? According to the source, you'd see, well, pretty much nothing at all. From that ultimate vantage point, the number 1 billion, even that monstrously huge number we were just talking about, they're all so far away that they just collapse into a single blurry dot. You can't tell them apart. And if you can't even see the numbers, how in the world can you count them? The The whole exercise becomes impossible. So we're left with this really provocative thought. What if these ideas, like different sizes of infinity, aren't some deep truth about the universe? What if they're just quirks that pop up because of our limited human-sized point of view? It forces us to ask, is infinity a real thing we can measure and sort into boxes? Or is it just the word we use for the edge of our own understanding? What do you think?